how secure is our C# code? So we've written a few C# programs at this point, and if you know a little bit about a programming language like C#, it differs from Python in the sense that it does actually compile down to a binary. And a lot of people have a tendency to assume that because it's an executable and you could just ship that executable to someone, they can run it on their system, that it would be a little bit more secure in that, you know, they're not going to be able to figure out your source code or things like that. And you can have, you know, maybe some sensitive variables that are just stored as strings and things of that nature. But this is completely, nothing could be further from the truth. And I'm going to show you in this video what kind of insight we actually have into the original source code, or how much information can we get about the original file? How much can we piece together if we only have the binary executable? So let's just jump right into it. So to illustrate all of this, I'll go back to the Commando VM. And if you recall from the last video, we created a simple networking tool. We'll use that for the demonstration in this video. If you haven't seen that one already, go ahead and check that one out. I uploaded that a few days ago, where we built this program out here, and all it's doing is connecting to our Kali machine on port 9001 and sending hello world. Now, I did add this little snippet here, a comment, just so we can see how comments, you know, is that something we can read using this technique that I'm going to show you in this video. But we're just using the stream reader, and we're writing and reading the stream in order to pass this hello world string across the network to our Kali machine. Now, if we want to, you know, before when we're running this, we were just hitting this play button here, and it was just running it. Now, if we want to compile this down into a binary executable that we could just run without having to have access to the source code, all we need to do is come up to build and select build solution. Alternatively, we could hit Control-Shift-B, but I'm just going to click this here, and you see build started, and it goes through, and it actually saves the file here. So this code will correspond to this DLL, networking.dll. But if we just take a look at this in our Windows Explorer here, we'll see a number of files were created in this directory here. So we have our networking DLL. It also generated a PDB file and an executable file here. So just to demo, in the future, we don't need the source code like I was saying. So if I actually come over to the Kali machine and I start the listener on port 9001, all I need to do is double click networking.exe, and you see it runs the program. And if we check back on Kali, it actually sends that data across the network saying hello world. So the program works completely fine without even needing the source code. Now that we've verified that, what information can we get from these files here? Obviously, the way this works is this executable here is relying on this DLL file. So if you were to ship this to a customer, they would need both the executable and the DLL file. Otherwise, this would not work, because a DLL file is essentially a dynamic linked library. So if you think about, if you're programming in a language, for example, you know, you're depending on other code if you're doing like imports and stuff like that, and you need those libraries in order for the code. It's a dependency essentially. So anytime you ship this executable, you also have to ship the DLL with it so that they can use it. So with that being said, I'm going to introduce a couple tools to you in this video. First, we're going to start as simple as possible and use a tool called ILSpy, which will actually allow us to what we would call reverse engineer these binaries in order to make a determination on what was the source code and see what information is available to us. But to really break this down so you can understand, I've created this simple illustration here on the screen, and I want to give credit where credit's due. I saw this from a YouTuber called Net Developer when I was doing some research, so much credit goes out to him, but I thought it was a really good infographic, so I would like to showcase this while we're walking through the process. So this is the C# compilation process. So it starts with the CS file, right? And that was just simply the code that we've written in Visual Studio and saved it to a file, the .cs file. That's what that is, right? And then from there, the C# compiler will run. So whenever we click build or we click debug and run, the C# compiler will first compile this down into what is known as IL code, or intermediate language code. So Java does something similar. It will first compile it down to Java bytecode. This is very similar to that. In C#, we call it intermediate language code, and that is where the exe file is created. So we saw that networking.exe is created in this step of the process. Now, this IL code here is a lot higher level than assembly or like straight up binary. So it's an intermediate, that's why we call it intermediate language code. So from this IL code, it is run inside the common language runtime. And when that happens, it is actually executed by the just-in-time compiler. So if you're familiar with Python, Python uses a just-in-time compiler on the actual code that you write here. The difference between that and C# is C# will first compile it down to IL code and then run the just-in-time compiler on the IL code, and that's how the binary is generated, the binary code, the binary ones and zeros, right? Which is the only language that the computer truly speaks when we get down to it. So this is the entire process, but because of this intermediary step here, we can use various tools. The one that I'm going to show you first is called ILSpy, where because this step exists, we can very easily estimate what, we won't know with 100% certainty what was in the CS file, but we can pretty accurately, as you'll see, pretty accurately guess what was written by the developer just by, leveraging the IL code here, using a tool like ILSpy. There's some alternatives you could use. There's actually quite a few. There's one called .peek. One that most pen testers and security professionals use is one that is called dnSpy. And I'll be showing you that a little bit as well. But all these things basically do the same thing, just with various features, bells and whistles, things like that. But the most simple one that you can actually get from Microsoft is ILSpy. So let's jump into that. So back on the Windows machine, what we can do is already have it installed. Come here, and I can say ILSpy. And this is what the program looks like here. Try to make it a little larger, but fit the stuff on the screen. The first thing we want to do is go to File and Open. And I'm already in the correct directory here. Let's first try to take a look at the executable file. So not too much information there, no metadata or anything like that. Really, where we want to look is, and if we come down here when we said build, it mentioned this networking.dll file. Most likely that is where our actual code and all the stuff that it's doing is located. So instead of the executable file, let's take a look at that DLL. So we open that. And now we can see a lot more information. Just from this first view here, we can see various information about the system that it was compiled on. We can see that it was, the architecture selected was any, right? Any CPU, which corresponds to this up here. And we can see a lot of information about how it was compiled and things like that. The hashing algorithm, the runtime, and even the PDB file where that's located. And we can even look at some of the imports that were called on the file, the assembly version, all kinds of stuff. Now, this is just the start. If we click this little drop down on the left, we can start looking into the metadata and the information that is stored in here. So there's a lot that we could browse through. First of all, if we kind of click through and look at the string heap, we can see a lot of the different strings that were called. These are the ones that relate to actual built-in .NET strings that were referenced. So since we're using, as a networking program, we see networking and stuff like that. Stream reader, that's, functionality we wrote in the code, if you recall. If we go to user string heap, we can actually see the values of some of the user created strings we have. So the host name, was this, right? We see the IP address here. We can see the message value of hello world. The people that are really deep into reverse engineering, I'm sure you guys could even tell me about stuff that I'm not going to cover in this video because I'm not an expert. This is not my area of expertise. But just really as a pen tester, if you can at least get some familiarity with this, know this is available out there, and it's always something you can go into deeper. And if you really want to get into binary exploitation and things like that, it would be very useful to do so. Now, if we go into debug metadata this is from the actual PDB file, we can see in the string heap here, these are all the variables that we declared: message, hostname, network stream, reader. See? So now you can actually look and see the variables. But it goes even deeper than this. It goes even further. So if we start, I mean, we can look at the references, obviously, but this part as well, we can take a look at the program itself. And what it's actually going to try to do is, based on the IL code, is going to try to reconstruct the source code. It's not always 100% accurate, but it's going to be fairly accurate. And if we look, we can see just how detailed this is. It looks almost identical to the code that we've written over here. Of course, there are some differences. For example, the imports, I did it a little differently. We just imported it this way, and some of the names are a little bit different. Yep, new TCP client, string hostname, I used var. So there will be some minor discrepancies, but as you can see here, just comparing the two, it is very accurately reverse engineered this program down to the variable names and the values for those variables. So if you could imagine applying this to a security context, this is why they say all the time that you don't want to store passwords as a string, because you can read it from the heap, you can reverse engineer it, and you can determine the password. So that is why, if you're familiar with, for example, the .NET library, they always recommend using the secure string. You know, if you ever used PowerShell before and you try to pass credentials, you would have to create a secure string, and there's a very particular way you need to pass it, and that is to prevent someone from just being able to reverse engineer and easily see that password in plain text. So that is why, yeah, security and how you store your variables, how you use your variables very much matter, even if you are programming in a compiled language like C#. You know, even if we weren't using Java or C#, instead we're using something without any intermediate language code like C++ or C, we could still reverse engineer it. We use different tools to do so, but the nice part about C# and Java for us as attackers is that it's a lot easier and more accurate even to reverse engineer from these languages because of the intermediate language code. And before we move on here, I wanted to point out that this comment here, we didn't see that anywhere in ILSpy. And the reason for that is that comments are not actually stored anywhere when it's compiled. They're not even part of that process. So they stay on the source code here, and they're not actually included in any kind of metadata or anything like that during the compilation process. So the next tool I want to show you is the one that security researchers and hackers use a lot, called dnSpy. We can basically see the same thing on there. Has a little bit more bells and whistles, cool stuff you can do. So definitely a good place to go next. So we'll just go back to that file and let's take a look at the DLL. We'll open that up. And very similar view we see here once again with this tool. And we can just start clicking through the drop down and things like that, getting information on headers, strings, different stuff. That's from the PE, the portable executable. We can also go back into the program, and this is what it came up with. Very similar to what we saw with ILSpy. Once again, very accurate reverse engineering of the code here. So obviously, there's way more that you could do with these tools. There's a lot more bells and whistles and features, but for what you need to know to get started, this would be pretty much all you need to know. And I think just understanding this is possible is a really huge leap forward. So yeah, hopefully this one was of help to you. Did you find it interesting? Did you find it helpful? Let me know down in the comment section below. And if you want to get into some more technical content, I have that on the screen for you right now. And as well, today is Thursday at the time of recording. So if you want to get into the network pen testing workshop, you only have one more day to do so. Check out the link in the description below for more information. I'll see you guys right over there. Thanks for watching.